I'm Steve Duckett. I'm going to describe and demonstrate a powerful but surprisingly easy method to model and simulate the spread of COVID-19 in the U.S. The TV and the internet broadcasts are filled with talking heads ready to prognosticate and pontificate on coronavirus scenarios that will affect thousands, if not millions of us. The professional epidemiologists have pretty good forecasts, but they run very complicated models on large computers that are just not accessible to ordinary folks like us. Since the professional opinions are quite often at odds with the opinions of other stakeholders, like business owners and politicians, we ourselves should be able to run a simple but sensible model on our own home computers in order for us to make better decisions, to understand the issues and the trade-offs. It turns out that a spreadsheet application like Excel is an extremely powerful way to model complicated, multivariable problems like the spread of an epidemic. The model here is easy to use for those familiar with spreadsheet calculations and allows simulations of various proposed scenarios in order to guide our judgment. We can demonstrate the basic idea of the model by doing a simulation of an infection spreading in a nursing home with 50 residents. And in the nursing home, very little mitigation is possible since residents are jammed together, and almost all have underlying problems which will lead to severe life-threatening infections. One column of the spreadsheet here is a timeline going week by week, starting in late January and proceeding actually for about a year and a half. This column over here is for the number of residents that have never been infected. It starts at 50. We said this would be a population of 50. And here it shows 50 just proceeding because we haven't infected anybody yet. We'll do that in a moment. This column for people recovered obviously is 0 since nobody's been infected. And then we have columns for mildly infected, severe infected, and total dead. These numbers up here are part of the parameters of any contagious epidemic. These are related to what is often called R0 or R naught, which is the replication, reproduction, contagion number. Here are some recovery rates, which are quicker for people that are mildly affected, etc. We'll talk about these a little later. So in any case, what we would like to do now is to put an infection in this shaded column over here. It's called seeds, is the number of people that come in and seed or infect the population at any time. And we'll start with a seed of 1 up here in just the end of January. And away we go. And you see that a week later we have infected people everywhere. Another week later, why there's 3 severe. Next week somebody dies, then more die, more die, more die. The population peaks somewhere in about the middle of March or toward the end of March, and then sort of stabilizes with 14 or 15 people that are dead. Okay, so that shows sort of what happens here. If we put another person in this, let's say we put him here, and essentially we get the same sort of thing because you can only infect so many and they'll die and others will recover. And in a small population like that, why the number of initial seeds is not very important. In a large population, it is. It's somewhat easier to see what's going on if we look at this thing graphically, which we will do next. This is a graph of the simulation we just ran, showing the mild cases, the severe cases, and the dead, the total cumulative dead. The peak of the severe cases is, well, let's see, here about the 10th of March, and it's pretty much petered out. This is a severe case here, sorry. Around the 17th of March for that one, and then it sort of peters out at this point. So we've added here in the calculation something to show what would happen if the total number of deaths were foolishly extrapolated to the results of the total population of the United States. That's really crazy because we're not 100% you know, nursing homes, but just to see what it is 30% died, and if it were in the entire United States, it'd be almost 100,000 people, 100 million people, a crazy number. However, the nursing homes are not a negligible part of the U.S. population. Certainly, there's maybe 0.5% or more of people who are in the nursing homes at the moment, and if 30% of those died, why then we would get of the order of 50,000 people, 500,000 people, I'm sorry, who would have died. So that's a very large number. And what it means is that we've got to protect our nursing homes and mitigate them as best we can, because otherwise, as time goes on, some infected person will come in and wipe 30% out. Now, we could, for example, change the parameters, for example. We've got these boxes here that show the fraction severe, the population, and the initial seed. Initial seed was, in fact, 0 in the beginning. We put them in later on. So let me put 1 in here right now, because it really makes not much difference. So, and we'll go and we'll take out these seeds that were there because we want to do a new simulation. And take this one out too. Okay. So suppose we have a different thing. Perhaps our 50 people are in a juvenile detention or a jail or something, and they're pretty healthy. So the fraction of severe might now be, let's say, 0.2 or 20%. We do the simulation again, and the total number dead are just 4, which is improvement, but it's still almost 10%. You'll notice also that because so many were mild and got out quickly, that the peak of the curve has gone from 17 March to about 3 March, two weeks earlier for the peak. So that gives you an idea of what could happen. But let's take it a little further. Let's suppose that we had a population, let's say, of 1 million. Okay, so let's see if I did that right. Okay, and remember now there's no mitigation here. So yes, the curve is pushed out until about August sometime, 11 August or so, but it's at 100,000 people infected at that point. We've completely overwhelmed the medical system. We have at the end 26 million, 27 million people who have died. So it's extremely clear that we need some severe mitigation here. This is, again, a non-mitigation scenario, and it's just horrible, just horrible. And people who said, "Oh, well, this is like the flu," just have no idea of how horrible things could be without the mitigation. Okay, so let's turn to cases now that do have mitigation, which is closer to what we're going to see in the real world, and so we will do that next. For a simulation with mitigation or distancing, we consider a population center of about 1 million, like a large city like San Jose. Since many carriers are known to be asymptomatic, we'll assume that the number of severe people severely infected is small, about 15%. For the initial seed, clearly it's going to be more than one. In fact, New York had more than 200,000 air travelers coming in from Europe and China in January. So we'll set this number to be somewhat larger, 12, let's say. Could be larger than that, clearly. So we'll run the simulation, and wow, look at the peak, and look how complicated it is. The reason for all of this is that in the beginning, nobody was doing anything. We had the exponential rise. Here, people started getting wise and starting to do some distancing, some mitigation, got really serious in here. And somewhere in mid-April or so, why the peak turned over, and continuing the mitigation, we can go down and down and down to a point where even the epidemiologists will say, okay, it might be okay to relax things. This would happen around toward the end of May, and of course things will shoot up, even though we've not relaxed to business as usual, and then more mitigation, more relaxation, etc. We're getting a little better at this, and as time goes on, but even around Christmas time, we have quite a bit of cases. Now, obviously, right in here where we are as I speak, there's a lot of political pressure to start easing things. And what I've got here is a way to show what would happen even if we eased only halfway for 3 weeks early, starting in essentially the last week of April. And this box here allows me to relax early, and let me put in the number, which is about half of a relaxation. Okay, and wow, you see that this peak is even larger. We went from what was 250,000 people dead over here to a great deal more. We're talking about picking up 1/3 of 1 million people just by relaxing early. So it's really very clear that it's critically important to get down to a lower level before we can start relaxing. If we ever want to keep ourselves from not killing millions and millions of people before we finally get a vaccine or something like that. So, well, this is enough to show how important the mitigation is, etc. And on part 2 of this, why I'll go into more details about the equations and the assumptions that go into the model. But for now, thanks for listening. We're going to say, try and have a good day.